the likeliness of two independent events happening. Go ahead and underline independent. In probability, independent events mean that these events are happening separately. The outcome of the second event does not depend on the outcome of the first event, unless it otherwise notes. All right, compound probability is denoted by one of two words in a word problem. It is either or it's and. Somewhere in the problem, it's going to say this or that, or it's going to say this and that. And that's how we know the difference. We use this notation, which you saw last week with the P, and then on the inside, it will be event A or event B. So if we are flipping a coin and we want heads or tails, it would say P, heads or tails. The rule is that you find the probability of the first thing, you find the probability of the second thing, and if the word is or, you add them together. Okay, if it's one or the other, you take their two probabilities and add the probabilities together. If the word is and, meaning I want heads and tails, then you multiply those probabilities together. So, and that's it. It's either you add or you multiply, and that's all. So we're going to go ahead and practice this. So let's look at number 1. You are rolling a 6-sided die 2 times. So I'm rolling it the first time. I want a 6 the first time, and then I'm rolling it a second time, and I want a 2. Okay? Here's the word. Go ahead and circle that. It says and. And means that I multiply. You may not need to write this out every single time, but I find it to be very useful to write the word and what it means, because you are more likely to remember it when it comes to test time. Okay, using our notation, I want the probability of a 6 and a 2. So that's how I would write this out in my probability notation. This is the same, right? So this equals finding the probability of rolling a 6 times the probability of rolling a 2. So let's find those probabilities first. On a 6-sided die, what is the probability that I roll a 6? 1 out of 6, right? There's 1 6 on the die, and there's 6 total sides. What's the probability that I roll a 2? 1 out of 6. And I need to multiply those. Do you remember how to multiply fractions? You go across. You do the top times the top and the bottom times the bottom. So what is the probability that I roll a 6 and a 2? 1 over 36. That's the final answer. That's it. Pretty easy. Okay, next one. We have a jar that contains 2 caramels, 7 mints, and 16 chocolates. What is the probability of choosing a chocolate, eating it, and then choosing a caramel? We've got a couple things happening here. First of all, what's my word? And. Circle it. And means multiply. How many total candies are in my jar? Yeah, Kobe said it was 25 too. Okay, I believe all of you. There are 25. So, we want the probability of choosing, I'm going to abbreviate, a chocolate and a caramel. And I abbreviated it. Just, those are long words. So this means I need to find the probability of a chocolate times the probability of a caramel. So what's the probability of choosing a chocolate out of this jar? 16 out of 25. Great. How many caramels are there? 2. When I make the second selection, how many candies are in the jar? How did you know that? You see where it says that he ate the chocolate, or we, whoever, ate the chocolate. That means that there is one candy taken away from the total, meaning that the second time around, my total is now 24. So the probability of picking a caramel second is 2 out of 24 because we ate one of them. That happens sometimes. They are usually very specific about telling you that something's not being put back in. If it doesn't say anything, we generally assume. In the last problem, there was no way that we could take a face off of the die, right? There is no way to do that. So that total stayed the same, but for this one, it specifically says something different has happened. And now that we have our 2 probabilities, we are going to multiply. This one's going to be fun. I know the top is 32. 25 times 24 is 600. Someone tell me why I am not done. We can simplify. Good. One more time, Gabriel. It's 4 over 75. These are both divisible by 8. I'll write that in really quick. If we do 32 divided by 8, it's 4, and 600 divided by 8 is 75. Good job. So we have to read carefully because sometimes you eat the chocolate, sometimes you put the chocolate back. Are we good so far? Cool. Number 3. Ooh, hold on, I'm stuck. You have a jar of 14 marbles. 7 are red, 2 are blue, 3 are yellow, and 2 are white. What is the probability of selecting a marble that is blue, putting it back, and then selecting a white marble? What's the word? And means multiply. How many total marbles do I have? 14. It said it right here. Sometimes it tells you, and that's nice. We want the probability of picking a blue and then a white. So we're going to find the probability of a blue and multiply that by the probability of a white. What is the probability of picking a blue marble? 2 out of 14. And what is the probability of picking a white marble? 2 out of 14. We put the marbles back, so we keep the total the same. Now, I'm going to call Kobe, because this is a thing we did a while ago. I can multiply straight across and then reduce my fractions, right? But I also see that I can reduce 2 over 14. What does that reduce to? So if I reduce 2 over 14 to 1 over 7 and 1 over 7 before I multiply, then after I've multiplied, I don't have to reduce a bigger fraction. We could have done that on the last problem too. I think it's easier to reduce 2 over 14 and 2 over 14 rather than reducing 4 over 196, because that's what it would have been. And 196 is a big number. What's my total probability for this? 1 over 49. Way easier. So far, so good. Great. Let's move on. I really like compound probability. All right. Let's try something different. You are spinning this spinner. What is the probability that you spin a 4 or a 5? Or, that's addition. So or means add. My notation is probability of 4 or 5, which I can rewrite as finding the probability of 4 plus the probability of 5. What's the probability of spinning a 4 on that spinner? Hold on. How many total sections are there? 8. And how many sections of those are a 4? 1. So there's 1 4 on the spinner out of 8 total sections. What about spinning a 5 out of 8? Also 1 over 8. So when I add those together, I'm sorry, do you have a question? Go on. The 4 and the, so you're spinning it twice, and on each spin you want a 4 or a 5. So you don't have to do it twice, but that was a good question. Thank you for asking that. You are just taking 2 chances to spin a 4 or a 5 on either one. So you only have to do it once. Okay, so conveniently, to add fractions, we have to have what? A common denominator, which we already have. It's 8, and then you just add the numerators. So it's 2 out of 8, which is 7/5 to 1/4. So the probability that you spin a 4 or a 5 on your 2 spins is 1/4. All right, number 5. I roll a 6-sided die twice. What is the probability of getting a 2, 4, or 6? Let me show you this notation because it's 3 things now. They are all or. So the probability of rolling a 2, or 4, or 6. That's how you would set it up in notation. And so we would expand this to say the probability of a 2 plus the probability of a 4 plus the probability of a 6. What's the probability of doing each of those? 1, right? A probability of a 2 is 1 over 6. Probability of a 4 is 1 over 6. Probability of a 6 is 1 over 6. Add them all together, and it's 3 over 6, which is 1/2. Good job. We actually technically did a problem like this last week when we did our simple probability. because if you look at a 6-sided die, there are 3 sides that are either a 2, a 4, or a 6. You kind of do that part in your brain without having to write all of this out, but it's helpful to see it on a problem that's simple like this, because eventually you get into more challenging compound probability problems where it's easier to have it written down. All right. Number 6. I like this question. On a spinner, there are 10 equal spots numbered 1 through 10. What is the probability of spinning a multiple of 5 or a multiple of 3? First of all, what's our word? Or. So or means add. It's right there. Now, this multiple business. On a spinner with the digits 1 through 10, which numbers on that spinner are a multiple of 5? Yep, no, you're right. 5 and 10 are both multiples of 5. What are the numbers that are multiples of 3? 3, 6, and 9. So, how many multiples of 10 are on my spinner out of the total? How many multiples of 10 are there? Multiples of 5. I misspoke. There are 2 multiples of 5 out of the 10. That's my first probability. Or 3 multiples of 3 out of 10. So when I add those together, I get 5 out of 10, or 1/2. So on a spinner with the numbers 1 through 10, the probability of spinning a multiple of 5 or a multiple of 3 is 1/2, because half of them fit that criteria. Okay. We're getting good. These are good. There are 27 students in a class. 13 are juniors and 14 are seniors. Do you know what juniors and seniors are at the high school level? What grade are juniors? 11th grade. Juniors are 11th, seniors are 12th. So we have a class of 27 students, some juniors, some seniors. It says, what is the probability of choosing a student that is a senior and then choosing a different student that is a junior? So it's and. So we want probability of senior and junior. So probability of a senior times probability of a junior. How many seniors? What's the probability of picking a senior? 14 out of 27 times 13. We're picking a different student, meaning that we have to subtract the one we've already selected from our pool. No chance of selecting the same student twice, so we have to subtract one. That's what they mean by a different student. So it's 13 over what? 26. 13 over 26. Hold on, 13 over 26. Oh, that's 1/2. I'm going to change that to 1/2 here before I multiply. So that's going to give me 14 times 1 over 27 times 2. It's 14 over 54. I can go one more time, but this is way easier than the numbers you were pulling out. Divide both of these by 2 to reduce it. 7/27. That's the probability of choosing a senior and then a different student that's a junior. 7/27. All right, we got one more. So good. All right, we've got a drawer that contains 4 red socks, 6 blue socks, and 10 white socks. What is the probability of choosing a red sock, replacing it, and then choosing a blue sock? How many total socks are there? All right, we got 20 socks. Why is the phrase replacing it underlined? What does that tell you is the question I should ask, Gabriel. They put it back. So the total doesn't change. That's what this means. The total doesn't change. So, probability of a red sock. What word is this and what operator is this? And, so multiply. And then probability of a blue sock. Red is 4 out of 20. Blue is 6 out of 20. I can reduce both of those fractions before I multiply if I really want to. 4/20 reduces to 1/5. And 6/20 reduces to 3/10. So when I multiply those together, my probability is 3 out of 50. All right, feeling good? Great. Little thing before I finish up. On the top of today's worksheet, there is some helpful information for you. Things that you may not automatically know, but that most math teachers would expect you to know. Let's talk about the high school grade level since we just did that, okay? Freshmen are 9th graders. Sophomores are 10th graders. Both freshmen and sophomore are considered underclassmen at the high school. Juniors and seniors are considered upperclassmen, okay? These are words you've probably heard before, but might not just automatically read and know what they mean. So that is listed here. So 9th, 10th, 11th, and 12th grade. Then cards in a regular playing deck, like what you'd play solitaire with. 52 cards in total. 26 are red, 26 are black. Of those 52 cards, you have 4 suits: hearts, diamonds, spades, and clubs. Hearts and diamonds are red, spades and clubs are black. Each suit has 13 cards. So 13 of each. And then in the entire deck, there are 4 of each type of card. There's 4 kings, 4 queens, 4 jacks, 4 aces, 4 of each. Okay, this is written out for you because as far as I'm concerned, when you get to high school, you are expected to just know this. But at this level, you may not know this. So it is written down here for you. This is all you should need to complete the worksheet for today. Okay? We good? Good job.